Hi, in this video we demonstrate the Canary deployment strategy with the help of a few Kubernetes resources. So for the purpose of this demo, we are going to revisit an earlier deployment we have created, the Blue app deployment. And then there was a homework assignment to build the Green app deployment as well. And then in addition to this, we will introduce a common service that will be able to route traffic to both sets of the pods, of the Blue application deployment and of the Green application deployment. Now, in our earlier demo, we've exposed the Blue application on its own service. Then the homework request was to create the Green app deployment and expose it on its own service. But now for the Canary strategy, we are going to create a common service between the two deployments. So let's head to the terminal and list our deployments. So keep control get deploy will list my deployments, and the two deployments that we'll be focusing on are the Blue app and the Green app, not the webs. So the Blue app we have created in an earlier demo. The Green app was our homework assignment. Now, they are both exposed via their own services. So we have a Blue app service and a Green app service, but what we're trying to achieve is to have one service expose them both. So in order to do this, we need to create a service, we need to create a definition manifest for a service, and then manually make some changes to ensure that the service will be sending traffic to both pod sets. So we'll run the kubectl expose command. We are attempting to expose the Blue app deployment. We rename the service as Canary. We're not naming it Blue or Green. It will be named Canary. The type will be node port, and we're using the dry run option to generate a YAML definition and then store it into the Canary service YAML file. But we are not going to create the service just yet. So enter. The YAML file has been created. And since we already know that a service needs to be configured based on its selector, we need to remind ourselves what common label we have between the Blue app and the Green app. So what we are going to do, we're going to run a kubectl describe pod command. So we're going to describe Blue app pod. And what we will do, we will grep for the labels of this pod. And it seems that I have three labels: app Blue app, the pod template for the hash of the replica set, and then the type Canary. Let's do the same thing with the Green app. And again, we're just going to grab four labels. We don't need the entire output. And comparing the two, blue, green, no, it's not. The hash is different. It seems that the common label is type Canary. Okay. So this means that my selector in the service, the common Canary service, needs to be set on the type Canary. So at this point, let's edit the YAML file. So we'll use vim canary service.yaml. A very simple definition file was created for us. So we can update the label just for consistency. We don't necessarily have to, because we should be focusing on the selector and not on the label. But it's okay. I can always update this as well just for consistency. So instead of app blue app, it will be type Canary. Now we just noticed that type jumped, and this happens every now and then when we edit YAML files. So before saving, we just want to make sure that we are bringing that field back to its correct position, to its right indentation. And this seems just about correct. Then we need to update the selector. Again, should be type. And should be Canary. We want to make sure that the selector type doesn't jump as well. So everything else seems to be correct. So now all we need to do is escape, X, and enter. Okay. So now we're ready to create the service. We'll use the kubectl apply command, and the kubectl apply command will just generate our node port type service. So we already know the minikube service list command. And the service we're interested in is the middle one, the Canary service. It has a URL because it's of node port type. So right now we have a single blue replica and a single green replica, which means that if I take into account the random load balancing of the Canary service, chances are 50-50 that the blue or the green pods will be hit with requests. So if I do this from the command line, because it will be easier to show the refreshes, we could run curl and copy paste the URL. Okay. So first is green, 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 blue, blue, blue. So far we have 3 hits on green, 3 hits on blue. So this is a 50-50. Green again, twice, then blue once, then green again, a few times. Now it's blue, green again. So it kind of alternates between blue and green. But for a Canary strategy, the idea is to have multiple replicas of the first application, the stable one, V1 or maybe blue in this case, and then the fewer should be of the green to minimize the chances of green receiving so much traffic. So what we can do is to scale out my blue application. So kubectl scale deployment blue app, and let's say number of replicas equals 5. So instead of 1 replica, as we've started with, I want to have 5 replicas of the blue application, but I will keep my green at 1. So if I run the kubectl, excuse me, get deployments, I will see that the blue app right now manages 5 replicas while green still manages 1. So now the chances have been lowered for the green application pod to receive traffic. So let's continue with curl. So it's blue. So in blue, it's majority at this point, right? So let's see blue, 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 well, green. Well, as we see, there's several blue hits, and then there's a green. Then there's several blue again, then there's a green. Right. So if you count them, you will see that the blue is receiving more traffic than the green app. So this is an implementation of the Canary strategy using 2 deployments and 1 common service in Kubernetes. So thank you very much for watching. Hope to see you in the next video.